Hello YouTube. Hello. Wait, just to show a quick image of who I somehow look like. Who I maybe look like. What I look like. Hello YouTube. Have it run. So, I've prepared a formula this time. I mean, we did. It's this idea, I think. Then we put up the formula. It's for many purposes useful. Actually, not that complex this time. It's not about time or I mean, almost all formulas are somehow in calculating that idea at not, but somehow, somehow. Sometimes at least it's weird. So this is basically the formula. We're just finishing it, then the phone went off. So 6 plus y plus 2 plus x2 equals x minus 1 plus 2 4. So that's basically the formula. What this is useful for is, for example, if you insert any degree to x2, possibility of calculating of linear equal to frame of, meaning, for example, to be calculated, of course, meaning, for example, if you want to construct something, if you try to build, to paint a picture by proportion, if you want to calculate an integral without in a non-to matrix of Gauss, for example, all these ideas, that's what it's useful for. So if you insert any degree to x2, you can already use it, but it's rather better used if y equals also as inserted degree minus one not 1, minus 4, for example, or better said, minus 2 times x2. If you insert that for y, you can use this formula easy, so that actually makes sense. Then you want to calculate x, of course. The rest of applications is, of course, usual for a mathematical formula. So it always works not like this, but only if you calculate further plus 3 in brackets, meaning like this. Under circumstances, second premise not always works, but always should be working if you insert y as minus 2 plus 5. If that is the insert for y, it will always work. Then you have a little to work around at some ideas of where degrees are rationalizing away the Euler idea by a variable to whatever would be that which is the kind of rivaling idea to Feynman. Always an important equation, though. So this is the equation, and if you insert that like this, then you should always have a result that is at least possible of linear equal to frame of, meaning that with this formula you should be able to then calculate at least something that would give an idea to, for example, if you want to build a frame of a framed square that would be based on quality sign, meaning for example a degree to be calculating or calculated out a frame. So that's basically what it means. So how we came up with this. At first we put up some premises. What if variable like sort accompanying x? Meaning, what if there's a variable that always is with x? It's of course not the same as x. It's not a lower case of x is not x. But what if there's an unknown variable always accompanying x in some cases of math, or maybe even all such? No. Is of not or such a value of y? Meaning, what if that variable that is accompanying x, if x plus something equals y, is always somehow involved in how an equation develops by what the algorithm defines. It's unnumbered constructed numbers, in derivation at least. Then x plus x, meaning this one, this x that is accompanying x, or also accompanying variable 1, is no count n, meaning it's not a counter like usually. It's not a plus 1 at all. So thus x equals sum of 0 to y over counter n. If that is true, then at least the sum of 0 to y cannot be 1 later, at least. Of course, logically. But if y is calculated over where the counter n, meaning m plus 1, this one here, is where the new variable is needed to be incirculated by the obvious made constriction or converted ways that abbreviation of a formula is to be or to be found by nullifying. Then the sum of 1 to n plus 1 would equal that variable nu, meaning x as the sum of 0 to y over counter n at when variable nu is of maybe occurrence to be seen, meaning occurrence to be seen, or occurrence, then the sum of 1 to n plus 1 is that variable nu, and x is the sum of 0 to y. X plus 3 by some random equals 0 plus something by definition, meaning by premise of n at least, somehow. And that, meaning x plus 3 by some random, is then calculated as x plus 3 under the, well, whatever, some random equals 0 plus something. So these were the three premises we set for when the search for the equation would starting the deconversion, meaning when it is of such a conversed idea in such a spirit of one that it is of derivation. Better word though, search for equation then starts, because variation is then also given in whatever would define the new formula. Now, soon we are at the result why this formula is then there displayed like this. Y is defined by n as long as not 0 or 1, but only if some random cannot be plus 1 by premise, meaning whatever is set as ground, or just set premise because this wording difficult, s over n. Meaning as long as y is not defined by the counter that plus 1 is, meaning n at least, then as long as not 0 or 1, the sum of random cannot be plus 1, meaning something plus 1, meaning n. If some random and y in this is of circulating vision to when it is of no belief or any constructed or occurrence by derived, then y never some random is y cannot equal 0 or minus something. This makes sense if you understand that y is defined by n as long as not 0. Meaning if some random is never 0 and y in this is y never some random, because x plus 3 is defined by some random to only equate to 0 plus something, then if some random and y in this y never some random is of such idea that x cannot be some random plus something plus 1, meaning n. And therefore, whatever is of the fundamental numbers that conflict not when abstract of y is to be seen, y cannot equal 0 or minus something. Because y never some random is something. As long as this holds true. And this. So if y not some random of any but y plus derivation of y, meaning y whatever, variable of nu is not in cause by x plus 3, any other than following reasoning. Why does this make sense? Well, because sum of 1 to sum of random compared by any other than no equation or lineage of where nu would be found by not derivation, then variable of nu is not in cause by x plus 3 any other, as long as y is only under circumstance of some random y plus derivation of y, as long as x equals at least to some degree the outcome that x plus 3 is also some random, equals 0 plus something, or at least some random. Meaning, if that all would hold true like this, y cannot ever equal what the sum is to be made unless some random. And that is then the counter that is not n that we are searching for, why the accompanying variable is to be found at some point but cannot be found yet. Therefore, some random will always be not y as long as this holds true with x plus 3 or x plus 3 equaling some random, or better said x plus 3 and x defined by that. Some x is some random. Of course, some random is not the same as some 0 to y, but the important idea here is that some 0 to y over n can always calculate to and calculate up by any number that is in combinated of not learned but constricting result of some random. And therefore, y, as long as not some random, which it can never be, is variable of nu not in cause by x plus 3, sorry. Meaning variable of nu is not in cause by x plus 3 any of other than following. And reasoned by this is that y then needs to equal something that is always in some idea undefining when x plus 3 occurs. And therefore variable of nu in cause by x plus 3 any other than then. By plus 3 unequals result 0. Meaning 1 cannot be x plus y whatever, meaning derivation of y equals y plus 1. Y plus 3 is then x or x2, and x2 is not the computation but computable and computated abbreviation of desolation, meaning x equals minus, meaning at least x equals at least result 0. Plus 3 equals result 0. Meaning, if that plus 3 unequals result 0. If that never comes true, 1 cannot be x. And if result 0 is unequaled by anything but what is of not x somehow, sometimes, then x or x2 needs something that is not of random 0. Or random 0 as long as result 0 is not true. No. So epsilon plus 3, meaning y plus 3, equals x or x2. X at least result 0. Makes sense as long as you understand that y plus derivation of y equals y plus 1 by result 0 defined by or x2, and as well x plus 3 equaling at least out always to 0 plus something, and not always, or any time, always, over deconstructing counter n. Thus, formula now given 6 plus y plus 2 plus x2 equals x minus 1 plus 24. If you insert any degree to x2 and insert y equals minus 2 plus 5, you always have any of these results somehow. And then it's usable. Because 0 is never the accompanying variable. Important. Much important. Yeah. So that formula is of this idea that then it has this result. Of course, it cannot always be used for this result and easily calculated for the degree it is, as long as you use a 10-4 or better said tangents by linear. Or if you don't want this idea to be doubled in whatever it would result to, tangents by rationalization. Rationalization. Of x cosinus. Somehow. Meaning cosinus doesn't need to occur. It's just some idea. Dangerous, maybe. So, if that's true, then it might be calculatable easy. The result, as said, is that you calculate from that degree a frame that is always in such idea that if used for a picture, for example, the ratios given are more easy to access. Or for example, if you want to construct a bridge, maybe not, maybe that's an good idea. So if you want to construct a lantern, the candle will, even in what is of angle, or better said, if you want to construct a lantern, the top of the we want to construct a lantern. The flame is not flickering to the outside image, meaning the glass or whatever, as long as that formula is used for the calculation of when the candle is inserted to be. Thank you, derivation. Equational, for listening.